In this video, we're doing a semi-recap of what right-angled trigonometry is. So there's a couple of things we need to recap. The first is the different sides of a right-angled triangle. So the first one is what we call the hypotenuse, and it's the longest side. It's also the side that's opposite the right angle. Alright? So the next one we look at is the adjacent side. So this is the side that's between what we call the focused angle, which is usually represented by that symbol there, which is known as theta, and the right angle. Adjacent also means next to, so you could think of it as the side next to the angle you're looking at. The next one is your opposite side, and this is the side that's directly opposite the focused angle. Remember that theta sign. So you should be able to draw a straight line leaving theta, and that side that it hits will be your opposite side. The next thing we're going to look at is our trigonometric ratios. So these are your sine, cos, and tan. So sine is the opposite side over the hypotenuse. We like to use SO to remember that because S stands for sine, O opposite, H hypotenuse. We then have cos, which is adjacent over hypotenuse, and then tan, which is opposite over adjacent. So each of these are ways to help you remember what's involved in each of the ratios. So, ka, toa, you may have heard it before. So is sine opposite hypotenuse. Ka, cos adjacent hypotenuse. Toa, tan opposite adjacent. So if we were looking at our triangle here on the right, if I wanted to find the sine of this, I know I can draw a straight line. That's my opposite, and my hypotenuse isn't there. So whatever that opposite number is, that would be on top. Again, if I wanted to do cos, it's my next to side adjacent there. Another two things it's important to remember when you're going into these type of questions is your angles of elevation and depression. So angles of elevation is if you were down here on the grass and you're looking up at a balloon, the angle from the horizontal until you look up at the balloon, that is your angle of elevation. Now your angle of depression, that is if you were up on top of a cliff looking down at something. So for example, you're on a cliff looking down at a boat. That angle of depression is from a straight line out from your eyes straight down to the boat. That is your angle of depression. With your angle of depression, it's also important to note that it is the angle of elevation from the boat looking up at you. Alright? Because those angles are what we call alternate angles, and they're the same. Now, I don't know if you remember this, but alternate angles form a Z shape. Alright, as you can see there. Alright, so the next thing we're going to look at is our worked solutions. So here we have a triangle, a right angle triangle, and we need to calculate the pronumeral. Now remember, pronumeral is just the fancy name for that letter there, so we're trying to find what y is. So the first thing you should always do is label the sides you have. Only label the ones that have values. So for example, I would label the 87 because that is my hypotenuse. And then I want to label my y. Now if I draw an arrow and it curves to go to the y from my given angle, that means that's going to be my adjacent. It's also right next to it, so adjacent. We then would have our so, ka, toa, and we have a look at which one of these matches what we know. So we know we have hypotenuse and adjacent, or A and H. So I need to look for which one of these ratios has A and H. I notice it's the middle one, so I know I'm going to be using cos. So what that means is I'm going to be using cos theta equals adjacent over hypotenuse. So I can start to fill these things out. Cos 42 equals my adjacent side, which is y, over my hypotenuse, which is 87. At this point, all we need to do is our normal rearranging. I know I have divided by 87 here, so I'm going to times by 87 to both sides. So what I'm left with is 87 cos 42 equals y. And if you put that into a calculator, your y comes out at 64.7 centimeters. Alright. Now I didn't put it over here, but these were centimeters, so it's important to make sure you do have your units there. Now the next one I'm going to look at is finding the angle this time. So it's the same kind of procedure. The first thing we want to do is label our sides. If I draw a straight line, that's my opposite. This is my hypotenuse. I know I'm going to have let me redo that. Toa. I'm looking for one that has an O and a H, and that's going to be here, so I know I'm dealing with sine. So sine theta is going to equal opposite over hypotenuse. So sine theta is going to be 5 over 8. And at this point, what we need to do is remove our sine, and we do that by using what we call inverse sine. Now, inverse sine, if you have a Casio calculator, is you press the shift button, and then you press the sine button, and that's going to give you inverse sine. So, theta is going to be inverse sine 5 over 8. And we do what we just said. You put shift sine into your calculator, put your fraction button 5 over 8, then press equals, and it'll come out as 38 degrees and 41 minutes. You may be given decimals, and it's important to note that if you press your minutes, seconds, your degrees, minutes, seconds button, you'll get converted to this, which is the appropriate form.